All right, AMP1 students, we're going to continue this video talking about ionic bonds. So in the last video, we talked about the ions and how they were formed. And so now we're going to talk about something that will happen when you form ions. What will happen is, because the ions are then, they have a charge, the ones that have opposite charges will be attracted to each other and they'll kind of form an attachment. And so we call that attachment or bond that forms between two ions, we call that an ionic bond. Now, because the opposite charges attract each other, we're going to get we can only get an ionic bond formed between a cation and an anion. So we can't have one between a cation and a cation because those are both positive, so they would actually repel each other. So that's what an ionic bond is. It's one of the chemical bonds that we're going to learn about. And so the ionic bonds will form between a cation and an anion. And once they form, we'll call that substance that's formed, we'll call it a salt. So salt is the term that you'll hear, and what that means is it's just a substance that was formed by an ionic bond. So a classic example is the common table salt, salt you use on your French fries and stuff. That is made up of the atoms of sodium and chloride. And I'm going to go to our PowerPoint here. So remember we talked about sodium and chloride when we talked about ions. That were the ones that we used as an example. So remember that sodium becomes an ion with a positive charge because it only has one electron in its outer electron shell. So it likes to get rid of it and it donates it to chloride, which needs it. And then when it does that, then it'll have that full 8 electrons in its outer electron shell, meets that octet rule, so then it's more stable. But then it does have a positive charge because it lost an electron, which has a negative charge. Same way with chloride, received that electron, and so chloride would then have 8 electrons in its outer electron shell and be chemically stable. But then it has an extra negative charge, so then it has a negative charge on it. So because these two, this cation, sodium, and anion, chloride, have opposite charges, they'll be attracted to each other and they'll form an ionic bond together. So that's the common example of a salt that's formed through an ionic bond. All right, now there are other substances, other atoms that will form ionic bonds. So one of them, there's quite a few, but we'll talk about magnesium chloride. And I have a picture of that one too, just to show you a little difference here. So the magnesium actually has 2 electrons in its outer shell, and remember it needs 8. So it'd be kind of hard to find 6 more. So what it likes to do is to donate its electrons to other atoms. So in this case, magnesium donated its electron to a chloride atom, and then it donated its second electron to another chloride atom. So then that allows it to have that 8 electrons in its outermost shell. But realize it lost 2 electrons. So instead of just having 1 plus charge, just 1 extra positive proton over electrons, it has 2. So it'll have a plus charge or 2 plus charge. And then the chloride, those are just still going to have 1 negative because they just both gained an electron. But again, whenever they they have this cation and these anions, they will form these attractions and then form this salt called magnesium chloride. All right, so let me go back to our objectives. So in this video, we described an ionic bond, and we described specifically the ionic bond of sodium and chloride. So in the next video, we'll talk more about other chemical bonds. So this is formation of an ion, and then the ionic bonds. That's one way that atoms will react to gain chemical stability. And then we'll talk about other ways that atoms can react with each other in order to gain chemical stability through that octet rule. So that'll be in our next chapter. We'll talk about covalent bonds and hydrogen bonds. I'll see you in the next video.